Good day, and welcome to Africa Teen Geeks. This is a STEM on digital school. If you have just joined us in here, this is a STEM digital online school. You have just come into the grade 12 physical sciences classroom. If you have just joined in, this is the grade 12 physical sciences class. Today is the 17th of July 2020, and guys, tomorrow, sorry guys, I made a mistake. It's the 22nd. Forgot to change the date, but please forgive me for that. It's the 22nd today because tomorrow is the 23rd, and we are going to be doing our first assessment. Okay, let me just move away from the screen with the incorrect date. We are going to be doing our assessment tomorrow. I've been telling you guys this since Monday that we are going to be having an assessment for term three. What are we going to be doing for term three? For term three, we're going to be doing our work, energy, and power and our Doppler effect. Remember, those are the two things that we did in this term. So I hope that everybody has been studying, has been understanding, and if you are confused, today we're doing a revision on work, energy, and power because we've already done a lot of the Doppler effect. If you remember, we spent a lot of time doing Doppler effect problems. So now we're going to be doing back to your mind, and also it will give you an opportunity that you haven't done or things where you're still lacking. Okay, so this is just a short we're going to be working from that I really liked and I thought book. So if you do have it, please go to the summative assessment and go to the summative assessment, and there you'll find all the problems and we can work through them. Okay. So my name is Nonkulego Matondo. I am your physical sciences teacher for grade 12. So I hope that you're ready to learn. Oh, another thing that I want to say is if you do not have that application, it's absolutely free and all the modules are including the study master textbook, not just for physical sciences, but for all your other subjects. So if you do require that, you can just download yourself. You can view your books online and offline. So as a matriculate, I think this is the kind of application that we need, to be more focused and to more, carrying books in our phones. Imagine having all your books in your phone. That would really be a nice thing to do. Okay. So recapping, I started these problems on number 4. Yes, I started the problem on number 4 because I just wanted us to go straight to the oh, I hate it when my computer jams, but we're working from the textbook questions, right? So here we are. So what does it say on number 4? It says, at a building site, Sfiso throws bricks to Kaya, who is standing on the ground. As the bricks are falling downwards, 4 meters above the ground. So here we ignore the resistance. Okay. So it starts on A. It says, if Kaya catches a brick that has a speed of 2 meters per second, use energy conservation principles to calculate the first one, the speed at which Sfiso threw the brick, and number 2, the maximum height above the roof reached by the brick. So here we've got this scenario here, right? So this is Kaya and this is Sfiso. So Sfiso throws a brick all the way up, but it passes Kaya's displacement and it goes a bit higher, and then he catches only when it comes back, right? So they want if Kaya they want the speed at which he threw the brick. Okay, they want the speed, the initial speed, basically the speed that is going up, and the maximum height above the roof reached by the brick. So which means for number 2, the maximum height is this height here because the roof is the height, right? So the maximum height above the roof reached by the brick. Okay. And then on number B, it says, explain why it is advisable for kite to allow the brick to pass it and catch it as it returns. Okay. So these are our three questions. So now we're going to go and check out okay. Okay, I'm just trying to get to our problem. The computer is quite slow today. Mm. Oh no. Okay, I'm just losing a bit of a grip on my own device. Mm, okay. You okay. Here we are. So sudden master exercises, right? So number one, it says that we're going to look for the velocity when the brick leaves the hand, right? So this is the initial velocity that we're looking for, right? So it's the one at the bottom. So they wanted us to, since the only force acting on the brick while it's in motion is gravitational force, mechanical energy is conserved, right? And why is there no force? Because they stated in the problem that energy is conserved, right? So which means that the mechanical energy at the bottom is equals to the mechanical energy at the top. So what that ultimately means is that remember with our mechanical energy, conservation of mechanical energy, it means that the potential energy before is equal to the potential. I mean, the mechanical energy before is equals to the mechanical energy after. So this is bottom and top, right? So on the bottom, we obviously know that we have no kinetic energy, right? So our kinetic energy at the bottom is going to be zero. And at the bottom, our kinetic energy is going to be zero. And our potential energy, we're going to have it because it's initial, okay? And after, after this, our we're going to have our MGH and our kinetic energy. We're going to have the both of them right at the top. But initially, because when you first hold the brick, the kinetic energy becomes zero, right? Okay. So MGH here, we've written it all. We've got our potential energy. We've got our kinetic energy. We've got our, oh no, our kinetic energy is not zero. I'm sorry about that. I'm just getting distracted. We are looking for the velocity here at the bottom, right? We're looking for this V right here because that's what they're looking for. And this is our MGH. And this is the aftermath, right? So on our first part, the potential energy, we're going to have 9.8 and we're going to have 1.5 meters. Remember, they said from the bottom to the maximum top, which is above the roof, it's going to be, it was 1.5 meters, but we do not have the mass, so we just leave the mass as it is, okay? And then you say half mv, this is the velocity we're looking for, and all of that will be equals to the mass times the gravity and 4 meters. Remember they told us that um, at the bottom it's 4 meters away. Let me just go back to the question, guys. I'm slowly getting okay. So we have it here. So the brick, this is the brick starts here, right? So the brick is 1.5 meters above the ground. So the initial velocity will be from 1.5 meters up below the ground, and then passes him and catches them while they are falling downwards 4 meters above the ground. So the after, remember this is the bottom and this is the top. So the top has a distance of 4 meters. Okay, so now I'm understanding everything right. So he catches the brick at 2 meters per second. So this is our final speed. So this is the speed of the brick at the top. It's 2 meters per second. So now we've got all our given ready. Now we can find the velocity at the bottom, right? We can find this velocity. We can find our velocity. I'm just trying to get a grasp on my arrow. Okay, so we can divide everything by mass because the mass is the same, but we do not have it. So you can divide everything by mass and we will have half v squared, and we take everything to the other side, to the right hand side, and you will be able to find your velocity at the bottom. So in this case, it means that therefore Sfiso threw the brick at 7.28 meters per second. Okay, always write that. Velocity has magnitude and direction. Okay. So if it throws already, it's a direction where it's throwing to. Okay. And then number 2, they wanted to know the height above the roof, right? Let's just go to that question there. It says in number 2, the maximum height above the roof reached by the brick. Okay. Maximum height above the roof reached by the brick. Okay. So let's see how that can be solved. So it says there that, okay, we know our mechanical energy before is equals to mechanical energy after, right? So what we're going to find now, we're going to be looking for the height, right? But we're looking for the height at the top. Remember the brick, there's a bottom and there's a top. And but we stop exactly there at the top on our maximum height. On our maximum height, we know that our velocity is 0. So which means our kinetic energy when on maximum height is 0, because when it goes on maximum height, when it gets to the maximum height, it stops, right? And then it goes down. So that point where it's on a 0 basis, that is our maximum height, where our velocity is 0, where our kinetic energy is 0. So we start placing everything before we do have, and now we're using the answer that we got for V bottom, right? So guys, make sure you've got all your answers right, because you see how they follow through on each other. So if your velocity at the bottom is wrong, your entire problem is going to be wrong. Okay. So on this side, our velocity is 0, and on this side, we're looking for the height of maximum. So we're going to divide everything by the mass again, and now we've found our maximum height. Okay. So, but they want the height above the roof, not the maximum, not the entire height. Okay. So therefore, the height above the roof is going to be 4.2 minus the 4 meters that we know the roof is, and that is going to give us 0.2. So it's basically 0.2 meters above the roof. Okay. Guys, I hope these problems make sense to you guys. I know it can be very tricky to understand some of the problems and how they found the solution, but I hope that you guys will have them right during your assignment. assessment tomorrow. Okay. So number B says, explain why it is advisable for Kaya to allow the brick to pass him and catch it as it returns. Yeah, that's a big one, hey? So let's see why. Why is it advisable? So it says here, it's advisable for Kaya to catch the brick on its return downwards because the time taken for the brick to reach will be greater. Okay, so it's basically the time spent for him to be prepared. You're coming up soft time to prepare for you to catch it. Okay, allowing him more time while the speed of the brick will be the same at the point where it is caught. Our now moving on, move to 5. Number 5 says a 0.04 kilogram bead slides on a curved wire starting from rest at point 0, rest at point A. So here it's at rest. So we know here we've got our mgh and our kinetic energy is 0, and then it moves. When it gets here, our mgh is 0 and our kinetic energy is there. So the path from point A to point B is frictionless. Okay, so it's frictionless. It means that our energy conserved. Okay, it's a conservative energy because once it has friction, then it's a non-conservative energy. So while the path from B to C is rough, so from part B to C is non-conservative, and part A to B is conservative. Okay, so now find the speed of the point B. That's the first one. Now, if bid C, if the bid arrives at point C with a speed of 1 determine the amount of work done by the frictional force in passing BC. Okay, so let's go and check out that answer, how we work that one out. So it says there, since the surface from A to B is frictionless, by the conservation of mechanical energy, we've got mechanical energy at A equals to mechanical energy at B. But like I told you guys, at A, kinetic energy is 0. Why? Why is it 0? Because we are at rest. Our bead at that time is at rest, right? And then at point B, like I mentioned to you guys, our potential energy in this case is going to be 0 because there is no gravitational flow of moving up and down. So it will be 0, but obviously because we came down with a certain velocity, so there at point B, we're going to have kinetic energy. Okay, so the minute there's movement, there is kinetic energy. So we're going to have these two substituted, 0 for kinetic energy and 0 for potential energy. What are we looking for? We're looking for the velocity at B. And then we start substituting everything that we have. That we've been given the mass and the mass on this side. And we're given, we know this is 9.8, G is always given, and the H is 0.8 meters. So this is our velocity is going to be 3.96. So now we're moving to B. B now, remember I told you guys that they said that it becomes a bit rough. So which means that it's got friction. So what does that mean? That means we now have work non-conservative. So for the motion from B to C, the only non-conservative force acting on the B is the frictional force. Therefore, we've got work is equals to change in potential energy plus change in kinetic energy. So we're going to maneuver them. This is potential energy plus kinetic energy at C minus the kinetic energy at B. Okay, so you see these two are the change in K and these two are the change in P. So now we put our mgh's there and our half mv squared there, right? Therefore, we move on now. At C, we know that our mass was, okay, the mass is the same for all of them, right? Our mass is 0.04 kilogram, right? And then our gram, this G, we know it on both sides. It's gonna be 9.81. So on both sides, we know it. And then our height at this case is 0.6 meter. At C, our height was given as 0.6 meters. But remember, at point B, at point B, we did, because now height is that other part, the part at the top, that's point C. But remember, guys, at point B, our potential energy was zero. So we have to substitute it here as zero, okay? And then we move on. Our kinetic energy at C, which is there at the top when it arrives at C, is going to be 1 meters per second, as they've stated that it gets to C at a velocity of 1 meters per second. And then for for the other one, it's going to be half mv squared. We're going to use our velocity at B that we calculated there, okay? So from there, you just add or subtract everything with each other, and you'll have your work done conservative, which will be minus 0.0584 meters per second. Okay, so let's move on. So now we're moving to number 6. Number 6 says two learners, Bongi and Sam, carry each carry a crate of the same mass from the ground floor of the building to the second floor of the building. Bongi takes 30 seconds while Sam takes 60 seconds to deliver the crates. A says compare the work done on the crates by each learner and explain your answer. Number B says compare the power of each learner. So for A, you're going to compare the work done. B, you're going to compare the power for each learner, okay? So now we go to number 6. So what we need to know with this case, assuming that each learner moves upwards at a constant speed and ignoring friction, work is done on the crates by applied force. So it's non-conservative force in each case, okay? So work done conservative will be equals to change in potential plus change in kinetic energy. And that will be mg change in h, basically, okay? Because our kinetic energy will be 0. So since the crates have the same mass and gain the same height, the work done in each case will be the same, okay? The crates have the same mass, they gain the same height because they go to the very same place, back and forth, and the crates have the same mass. The work done in each case will be the same. Okay, but now when it comes to the time, there's going to be a slight change because now when we do deal with power, we have to deal with time. And in this case, one is moving at a faster speed than another one. So the time taken for one of them to go and take the crates up and come back is much lower than the other time taken. So the time is indirectly proportional to power. So it's same for both the learners. So the longer the time or the greater the time, the less power that is used, right? So in this case, change in time for Bogie is greater than change in time for Sam. So which means that Bogie will have a greater power than Sam because her time is much less than sand. Okay. I hope that it makes sense for you. Then we move on to number 7. Guys, I hope all of this is making sense for you guys, and it will make it easier. If you can understand this, you'll be able to understand your test tomorrow, okay, your assessment tomorrow. So on number 7, it says a car is traveling at a horizontal road at a constant speed of 100 kilometers per hour. If the power delivered by the engine is 20 kilowatts, what is the magnitude of the frictional force opposing the motion of the car? So the car has a horizontal constant speed of 100 kilometers per hour, right? So if the power delivered by the engine is 20 kilowatts, what is the magnitude of the frictional force opposing the motion of the car? Okay. I know, guys, this thing can be tricky, especially with so many formulas. Work done conservative, work conservative, all of these things, they can really get to a person at some point. But guys, be patient. Just take what you have. Write everything that you have done. You've got velocity, you've got power. So what does that mean? It means that because our it's not at constant speed, right? Then we can use the power is equals to force times velocity formula. And therefore, we will substitute the velocity that's given and the watts that was given. And don't forget, guys, we do not work with kilometers per hour. So first of all, we have to convert it to meters per second. And that's going to be the 100 times 1,000 divided by 3,600. The 1,000 is for changing kilowatts to meters, right? And the hours to seconds, it's going to be 3,600 seconds, okay? And that's how you get it. And therefore, the magnitude of the frictional force is 720 newtons, okay? Guys, our time is almost up, but I hope that everybody is coming through. We're just going to do the last one, which is number 8. It says, a 1,000-kilogram elevator is moving upwards at a constant speed of 3 meters per second. If the elevator has one passenger of the mass 50 kilogram and a constant frictional force of 2,000 Newton opposes the motion of the elevator, what power is delivered by the motor to deliver the elevator? Whew. So you see, guys, with work, energy, and power, there's many problems. There's elevators, there's stairs, there's inclines, there is pulleys, there is pipes. So these are all problems that have to do that you need to be able to work out on your own. Okay. So let's see. So now they're dealing with an elevator and they want to know, so the force applied by the motor on the elevator, which is force applied, must balance the weight and the frictional force downwards, right? So since the net acceleration of the lift is 0, the force applied will be the gravitational force plus the frictional force, because like they said here, they must balance the weight and the frictional force downwards. So it must be balanced for the force that goes upwards, and that's going to be 1,000 kilogram plus 50 kilogram times 9.81. Okay, this is 1,000 kilogram, and this is the mass of the person inside that elevator, and that we're going to add it with the frictional force. So now we have balanced our applied force to the gravitational and the frictional force, and therefore we need to get the power. So the power will be the force applied times the velocity. Velocity has already been given as 3 meters per second. So which means that our power will be 36,870 kilo joules per second or watts or kilojoules or 36.87 kilowatts. Okay, so that brings us to the end of our lesson, guys. Thank you guys so much for joining me here for our revision questions, even though we haven't done all of them. But I'm just glad that we did as much as we can just to refresh your mind with. But remember, guys, if you know the difference between conservative and non-conservative energy, potential energy, kinetic energy, the conditions that bring them together, guys, mechanical energy, you guys are going to be all good. So remember, the mechanical energy is equals to the change in kinetic energy. So those are little things, are little factors that you guys need to know, but we've already done revisions for those things. So I do not think that you guys are going to have a problem there. But nonetheless, this is me, Nonkulego Matondo. Um, you can catch me on T33T@gmail.com, and you can ask me any further questions. And with regards to tomorrow's assessment, guys, please be on time so that I can be able to guide you guys through the whole assessment and when to start answering which problems and how much time you have left, etc. Okay, thank you guys so much and goodbye.